in the realm of analytical chemistry. LCMS is a beacon guiding us through the labyrinth of molecules, illuminating pathways to new discoveries. On this note, a very warm good morning and a hearty welcome in today's international session titled Application of LCMS. To pray is to change. This is a great grace. How good of God to provide a path whereby our lives can take over by love, joy, peace, and patience, and kindness and goodness and faithfulness and self control by Richard Foster. With this in mind, we'll begin this event with a moment of silent prayer. Liquid chromatography mass spectrometry, or LCMS, is a sophisticated analytical technique used to separate, identify, and quantify components in a mixture. It combines the principle of liquid chromatography, which separates compounds based on their interaction with the stationary phase and a mobile phase, and mass spectrometry, which ionizes and analyzes compounds based on their mass to charge ratio. LCMS is widely used in pharmaceuticals, environmental analysis, food safety, and biomolecule due to its high sensitivity and selectivity. It has revolutionized analytical chemistry by enabling rapid and accurate analysis of complex samples. We are pleased to have Dr. Ravindra Singh Thakur, a postdoctoral scholar from the Ohio State University, USA, join us today. Welcome, sir. I also welcome Mr. Don Cairo, the coordinator of the Department of Forensic Science, to this session. Welcome, sir. I especially welcome all the faculty members and the students of this session. We hope this session will enlighten you and provide you deep insights in the topic applications of LCMS. Welcome, all of you. Without further ado, Neha, is going to introduce the guest of the day. Dr. Ravindra Singh Thakur is a highly accomplished researcher specializing in chemical sciences, currently serving a postdoctoral scholar at the Ohio State University in Columbus, Ohio, USA. With an extensive educational background, including a PhD in chemical sciences from the Academy of Scientific and Innovative Research, Ghaziabad, India, Dr. Thakur has focused his research on critical areas such as environmental contaminants, analytical chemistry, toxicology, and forensic science. Dr. Thakur's academic journey also includes an MSc in forensic science and a BSc in chemistry, physics, and forensic science from Dr. Hari Singh Gaur University, Sagar, providing him with a well-rounded foundation for his diverse research interest. Throughout his career, Dr. Thakur has received numerous accolades, including Best Poster Award and a prestigious fellowship from organizations such as University Grand Commission in India and the Ohio State University in USA. His contributions to scientific literature are substantial, with several peer-reviewed journal publications including Elsevier and Springer, Nature. He had also presented his research findings at national and international conferences, with the recent one at annual meeting of the Society of Research on Nicotine and Tobacco, held at Edinburgh International Conference Centre in Edinburgh, Scotland, United Kingdom. His current research as a postdoctoral scholar at the Ohio State University, Columbus, Ohio, USA, focuses on the project funded as well as in collaboration with by organizations like FDA, CDC, and NIH, emphasizing the comprehensive chemical characterization of various substances and the potential impacts on public health. He is also a principal investigator of the project funded by the NIH Tobacco Center of Regulatory Sciences at the Ohio State University. with expertise in analytical techniques such as mass spectrometry, chromatography, method development, and toxicology. Dr. Thakur brings a wealth of skills to his research endeavors. Moreover, his teaching experience at the institutions like Tirthankar Mahavir University and NITTE University underscores his commitment to academic excellence and knowledge dissemination. As a peer reviewer for esteemed journals of Elsevier, as a member of professional societies like Society of Research on Nicotine and Tobacco, Best Practice on Non-Targeted Analysis Working Group, Tobacco Regulatory Science, the Indian Science of Congress Association. Dr. Thakur actively contributes to the advancement of scientific knowledge and the promotion of best practices in this field. He is well known for his work in the field of regulatory toxicology and analytical chemistry, with a specialized work on areas of non-targeted as well as trace analysis. Driven by a passion for research and a dedication making meaningful contribution to society, Dr. Ravindra Singh Thakur stands as a distinguished scholar at the forefront of chemical sciences, poised to address complex challenges facing our world today. Sir, we welcome you to this session.
Thank you. So shall I start sharing my screen?
Yes.
Yeah. Okay. Good morning, everyone. So today I'm presenting on the topic liquid chromatography and mass spectrometry. So first, we discuss about chromatography. What is chromatography? Chromatography is basically derived from a word, Greek word that is chroma and graphene. That means to write with color. And it is basically a separation science which involves the two major components that are the stationary phase and the mobile phase. Stationary phase can be of various types, such as paper as well as thin layer. Then after development, it comes to the column chromatography, and then the packed column and as well as the thin layer column. And when talking about the mobile phase, the chromatography has a liquid as well as gas mobile phase. Now, with the development, it also involved supercritical fluids. Talking about the principle which chromatography involves are the partition principle. In this, the solute parts or the analyte follows up principle of partition, and it separate in between, or it interact with the liquid layer as well as the flowing liquid, and get partition based on their partition coefficient. Secondly is the adsorption chromatography. In the adsorption chromatography principle, these analyte got adsorbed on the surface of thin layer. And coming to the ion exchange chromatography or ion interaction chromatography, this chromatography are generally involved in the speciation of metals or some metal containing proteins and deuterions. Coming to the size exclusion chromatography. So in size exclusion chromatography, it is sometimes termed as the gel permeation chromatography. In that, separation is happened based upon the size of the analytes which we are analyzing. And coming to the affinity chromatography, so affinity is basically the intermolecular attraction in between any analyte and the stationary phase. So this type of chromatography basically involved in the biological experiment, such as like when we are separating some kind of enzyme or proteins, or some kind of targeted analysis, such as like mm, uh, you can say target molecule like a specific drug, or having different chirality compounds, having different chirality in between them. So these type of like specialized columns are prepared, and then the affinity chromatography is performed for the separation. And uh, we already know that chromatography is divided into two types based on the mobile phase, that is the liquid chromatography as well as gas chromatography. So liquid chromatography, stationary phase can be two-dimensional as well as three-dimensional. So two-dimensionals are the plate and paper, that is a thin layer chromatography or the paper chromatography, as well as the packed column such as HPLC or column chromatography. And the mobile phase used here is the liquid. And coming to the gas chromatography, so mobile phase involved is gas. In a stationary phase are previously there are the packed columns. Nowadays the columns come in the form of thin layer films inside a capillary bore. And chromatography, based on the type of principle they employ, it can be further classified as the paper chromatography, thin layer chromatography, gel permeation chromatography, or size exclusion chromatography, as well as ion exchange chromatography, affinity chromatography, and supercritical fluid chromatography. Chromatography, sometimes you heard that it is a normal phase chromatography or reverse phase chromatography. So the normal phase chromatography are the where it involves polar stationary phase and non-polar mobile phase. Generally, the stationary phase are the silica embedded inside the column. Uh, in the reverse chromatography, the stationary phase are the non-polar or hydrophobic column containing silica with the chain of carbon length, maybe C18 or C8. Uh, Based on the analyte you want to analyze, you can select the stationary phase. And the mobile phase are generally polar in nature. Chromatography is sometimes termed as the planar as well as column chromatography. So when we're talking about the two-dimensional, that is planar chromatography, and when we're talking about the three-dimensional, that is column chromatography. So planar chromatography can be paper chromatography, thin layer chromatography, high performance thin layer chromatography, and for the column chromatography, this can be HPLC, that is high performance liquid chromatography, gas chromatography, gel permeation, ion exchange, affinity, and supercritical fluid chromatography. In planar chromatography, we determine or analyze any compound based on their retardation factor, and in the column chromatography, we determine compound or analyze any compound based on their retention factor. Uh, Before moving further, I just want to discuss what are the theoretical plates and how they involve in the separation as well as the identification of the analytes in chromatography. So theoretical plates are basically considered as the ideal situation where the column is new, and they like the separation of any analyte or the resolution of analyte based on the number of theoretical plates present inside the column. So in previous days, when we are using like paper chromatography or thin layer chromatography, the number of theoretical plates are less. But now with the advancement on the technology, we are using nano column and sometimes the thin film column. So the particle size is less, much lesser, like in microgram or some micrometer, or sometimes picometer also. So we are able to generate much number of theoretical plates. So the greater number of theoretical plates is the higher the resolution, higher the sensitivity and separation in between two closely aligned analytes. So this is the formula utilized for the analyzing any number of theoretical plates present inside any column. When the column is new, the theoretical plates are much higher, but with the passage of time or utilization of the column, theoretical plates become decreased because their particles size or dimensions used to change with the passage of time. Coming to so the basically theoretical plates are considered as like multiple plates present inside a column. They are not like physically present, but ideally we consider it as a plate, like the layer of any ions, or not ions, binding molecules or a stationary phase. They form a one plate, and then the second plate, and then further on. So this way they divide like in a theoretical plates, but they are theoretical. In physical, they are only the particles with a smaller diameter. So and then there is one equation, that is 1D metric equation, which involves the chromatographic separation. So here you see the theoretical plates is it is termed as the theoretical plates, is sometimes termed as the height equivalent to theoretical plate. So basically these plates depend on the flow as well as the kinetics of the flow or the analyte in column with interaction with the mobile phase as well as stationary phase. So you have seen in the rafting when you are go for rafting, there are like river and there is a streamline flow. But what happened with the presence of the pebbles in the river, there are currents generated. So these currents are like similarly in the streamline flow of liquid or the mobile phase inside the column, there is a presence of particles. So these particles generate the eddy diffusion as well as longitudinal diffusion and the mass transfer of the to the stationary phase of the analyte, and as well as the mass transfer of the analyte to the mobile phase. And it also involves the linear velocity because it is moving inside the column. So how this one dimensional work equation work inside the column? It works similar to the river with which contains stones, pebbles, and rocks. So what happened? Uh, Here you see. Oh, wait. So here you see there is a particle, or you can say a particle inside the column present. So when any analyte come in the any particle come in the path of analyte or liquid, these liquid change their path and they generate a current. So this current is termed as the eddy current in Bundy-Metric equation. And when these particles used to pass through different like different path, not a straight path or a streamlined path. So this is a longitudinal diffusion which is happening in between the stationary phase and mobile phase when analyte pass in between these particles of stationary phase. And then further it happens like when any analyte like this bigger analyte used to pass through the like not bigger analyte, cluster of analyte used to pass through the molecules of the stationary phase. These particles got accumulated on the surface of the stationary phase, as well as they used to migrate with the mobile phase. So this is the and this is the distribution of the analyte in between the stationary phase and mobile phase, which we involve in the one dimensional equation. And the linear velocity is the velocity that is the mobile phase or the flow rate of the mobile phase which we are using. Based on this equation, we can theoretically calculate the number of theoretical plates involved in or present inside in any column. Coming to the chromatographic techniques. So chromatographic techniques can be defined as a collective term or set of the laboratory equipment which are combinedly used to separate as well as analyze any compound or mixture of compounds. So there are numerous chromatographic techniques. So we can say that like high performance thin layer chromatography, high performance liquid chromatography, gas chromatography, and supercritical fluid chromatography, etc. So today we are discussing about the high performance liquid chromatography. So in high performance liquid chromatography is a sophisticated analytical technique which used improvised column or with the mobile phase, which is pumped using a solvent which involves the pumping of the mobile phase with the high pressure using a pump system. Pump can be binary or quaternary pump. So based on the number of like solvent you are using for the separation, you can use binary as well as quaternary pump. It is based on the it is also based on the availability of the pump which you are having. It is and coming to the stationary phase. So stationary phase in previous time is like a glass column, but with the passage of time, these particle size which are used in the glass column are maybe like 2 millimeter, 1 millimeter in diameter. Now the particle size of the stationary phase are much less. They are in 1 or 2 micron in the particle size, so they are like uh, tightly packed inside the column. And this tightly packing of a column and a smaller particle size provide the high performance of the separation in the chromatography. And this separation, this technique is also used for the quantitative as well as qualitative analysis of analytes present in any mixture of biological compounds. The detection and the detection limit of the HPLC depends on the type of detector you are using. So if you are using refractive index detector or evaporative light scattering detector, it detects up to microgram level. But when you are using UV detector or photodiode array detector, it can detect up to nanogram level. And when you are using fluorescence detector or amperometric detector, that is uh, electron electron conductivity detector. So that can detect up to picogram level. Uh, I already told that the number of the theoretical plates are higher. The maximum is the separation, and maximum is the resolution in between two closely aligned analytes. Uh, the smaller particle size present inside the column packing give the higher efficiency to this column. And sometimes column in a chromatography is termed as the heart of column, because everything or every separation is happening in the chromatography is based on the column which we involve during the analysis. Coming to the principle, so based on the type of stationary phase you are using and the mobile phase you are using, principle can be changed in the high performance liquid chromatography. Principle can be adsorption when you are using any C18 column, and as well as partition when you are using any C18 with certain mobile phase, in which analyte partition in between the stationary phase layer of the solvent as well as the mobile phase layer of the solvent. And when you are using the ionic or the ionic buffer and the ionic exchange column, then ionic principle, ion interaction or ion exchange principle is involved. And when you are analyzing any specific biological analytes, then affinity comes in role. Coming Talking about the mobile phase, so mobile phase is basically stored in the reservoir, and they are flowed using a high pressure pump, and the pressure can be range from in HPLC it range from like 0 bar to 600 bar. When we are talking about the UHPLC, it can go up to like 1000 bar, and when you are talking about UHPLC, the pressure can go up to 1500 bars. And the flow of the mobile phase can be isocratic or gradient. So isocratic flow, it means it remains constant from the starting to the finishing. During the whole run, the constituent and the flow of the mobile phase remain constant. In the gradient flow, you can change the mobile phase constituent as well as the flow rate. So there are so the mobile phase can be used in two ways during the separation. Generally, when we are analyzing any single or two compounds, we are comfortable with the isocratic phase uh, flow of the mobile phase. But when we are analyzing multiple compounds, maybe 100 of compounds in a single run, then you are going to use the gradient phase. In the chromatography, components got secreted based on their affinity and interaction in between the stationary as well as mobile phase present inside the column. So this is the schematic diagram which you already see in your books, that contains HPLC, contains the solvent reservoir having solvent. This solvent is pumped using the pump. Then after the pumps come the injector where you inject the sample. Nowadays comes auto sampler is coming in a form of injector, and then comes the HPLC column. And after the column, analytes got separated and they got detected by using different type of detector. And these then further our solvent will go into waste, and the data we can record using the analyzer, that is a computer system. So this is the water's HPLC system. So here you see this is the reservoir, this is the pump assembly, this is the temperature control module. So when you are separating any analyte in a column, they sometimes recommended like you have to keep column at 45 degrees Celsius, sometimes 60 degrees Celsius. So talking about the sugar analysis, sugar are like when you are analyzing any sugar or carbohydrate component, they used to accumulate inside the column. So you have to need high temperature for their separation as well as analysis. So that's why we require temperature control module for the column. Then comes the auto sampler. So here auto sampler injector is present inside the auto sampler. You can give the address of a vial, and then auto sampler automatically take your vial and inject inside the system. And then comes the different type of detector. So here we have four detector attached with one HPLC system. So we have a PDA detector, ELSD detector, RI detector, and ECD detector. And there are also the fluorescence and mass detector, which is not attached with this system, but it can be attached by any HPLC system. So coming about the results of HPLC, how you are getting the result in HPLC. So this is a result of uh, a polycyclic aromatic hydrocarbon. So this is separated by using C18 column using the mobile phase of acetonitrile and water combination in isochaotic flow. But here the analysis is happening based on the area inside the under the curve. So here you see different type of peaks. So there are 16 targeted peaks present in this standard, and we are analyzing sheet banded noodle samples. So some of them present in the noodle samples. So how do you identify and quantify any compound or any phs present in the sample? So here you see the peak, like this peak, that is the naphthalene, the first peak, which is highlighted in the one. So naphthalene has a specific absorption near about 254. So this is the absorption spectra. So based on the retention time as well as the absorption spectra combination, you can say that, okay, this compound is present, and based on the area under the curve, you can say that this much quantity of a naphthalene is present inside the sample. So this is the result of HPLC attached with photodiode array detector. Coming to the detection techniques which we can involve in the HPLC or the with the liquid chromatography. So there are different type of detectors such as PDA, photodiode array, fluorescence detector, ACD, electrochemical detector, refractive index detector, LSD, and ICP-MS and MSMS and MS. Uh, So coming to photodiode array detector, this involves the Beer-Lambert law. It is basically based upon the absorption of intensity of the light when it passes through any mobile phase or as well as analyte. So when any light rays, that is the incident light rays and transmitted light rays pass, so whatever there is a difference in between the change in the intensity, that is termed as the absorbance, and based on the absorption, how much absorption it is happening by the analyte, we can analyze as well as quantitate the analyte present in a sample, such as like talking about the pH. So if it is giving the 254 nanometer absorbance, that is in the UV region of spectra, we can say that, okay, pH is present. Then how much it is present, it is based on the intensity of the light absorbed. And here in this diagram, you can see the photodiode array. So this is basically a UV or visible detector in previous time. But what happened, the sensitivity is less. You can detect up to like microgram or sometimes milligram level, not in like picogram or nanogram level. So to increase the sensitivity, they employ the UV lamp, then they employ reflector, and then it pass through chromatography, and uh, it pass through the sample here, and then it goes to the monochromator, and this monochromator then goes to the array of diodes. So they are the diode array which can convert or multiply an electron into million times of a, which can multiply a single electron into a million electron. So this will increase the sensitivity of the analysis. So this is the photodiode array detector. And talking about the fluorescence detector, so fluorescence detector are basically used for the compounds which are having chromophores or unsaturated bond present inside between them. So what happened when any analyte comes in the path of the you can say incident wavelength? So these analyte then got excited, and then the excited wavelength is captured by the detector. So talking about the bisphenol A, that is a carcinogenic. Uh, it has a excitation wavelength of 220 nanometer, and when bisphenol A interact with the 220 nanometer wavelength, it goes excited and it emits the specific wavelength of 300 nanometers. So this specific wavelength of 300 nanometers is then captured by the detector, and further it is quantified by uh, using fluorescence detector. So if any compound is not fluorescence active, then we can tag it with a fluorescent active dye, and we can also analyze any fluorescent inactive compound in using fluorescence detector, because the sensitivity of the detector is picogram, or you can detect up to parts per trillion level. So this is a uh, good detector to detect any trace level of compounds. Coming to the electrochemical detector, so electrochemical detector basically depends on the presence of oxidation species in the analyte. So whenever any analyte come in between these potential like negative and positive electrodes, and there is a thin film of the analyte generated in between these films, and this thin film generate a difference in the potential based on the oxidation or the reduction. And so based on the difference in the potential generate, it gives a peak in the spectra. And this is also highly sensitive because a like minute difference generate a major signal, and it is also sensitive, similar to the fluorescence detector. But here and there is a catch, like it requires ion pairing reagent in the mobile phase. In the fluorescence detector you can use acetonitrile water as a mobile phase, but here you will require ion pairing reagents with the mobile phase, so that ions can be paired with the analyte, and then these ions generate potential in between two electrodes. So this is the electrochemical detector, which these electrochemical detector are generally used for the neurotransmitter analysis in the sample. So such as like in case of organophosphate poisoning, there are change in the neurotransmitter such as acetylcholine esterase inhibitor. So these acetylcholine can be detected by using electrochemical detector, and neurotransmitters are much less present in the biological sample when you are talking about any dead body or corpse. So then this technique is very much helpful, or this detection technique is very much helpful when we utilize with the chromatography. Talking about the refractive index detector is sometimes termed as the universal detector because each and every compound present in this universe have a specific refractive index, and when these compounds come in a path of um, light, so they refract the light up to certain angle, and this refracted light can be detected by the detector. So there is a reference signal as well as the signal from the analyte, and based on the difference of these two signal, refractive index can be generated, and based on the refractive index you can analyze any sample. So these are generally used by industry for the analysis of sugars and some pharmaceuticals uh, in the sample or in a active components. Coming to evaporative light scattering detector, so this is a detector in which analyte is nebulized by using the nitrogen or inert gas. When the analyte come outside the column, it is then nebulized by using the high flow of the gas, 50 psi per minute, and then these bigger molecules converted into or fragmented into smaller molecules, and the light source fall on that. So based on the scattering of the light, these specific analytes having a specific scattering wavelength. So based on the specific wavelength, scattering wavelength, we can analyze or identify and quantify any compound present in the sample. So this is also used for the carbohydrate as well as pharmaceutical analysis. Talking about the inductively coupled plasma mass spectrometry, that is ICP-MS. So when you are generally you heard like we can analyze sample by using ICP-MS for metal analysis. But why we require LC, ICP, HPLC coupled with ICP-MS? Because when we are talking about like some speciation elements such as chromium 3, chromium 6, there is a like cases comes where there is a poisoning of chromium happen, or it may generate from the environmental sample or any food sample. Then not in India but in foreign countries, people ask like what type of chromium species present inside the biological system. So when you are analyzing any sample using the ICP-MS or AES, AAS, then you are not able to specify like how much quantity of the chromium 3 and chromium 6 present. But by using HPLC, you can separate chromium 3 and chromium 6 in two separate peaks. Then you can analyze them using the ICP-MS. So here, the analyte goes inside the ICP torch, and this ICP torch evaporate and ionize the element present, and this element is further detected by the mass detector, that is a quadrupole detector, and these signals are then further multiplied by electron multiplier tube or photo multiplier tube. So it has detection up to parts per trillion or parts per femto levels. So this is highly sensitive technique for any elemental analysis or any metal toxicity. Talking about the mass spectrometer, so in the mass spectrometer, it is a highly sensitive and advanced technique for the analysis. So here, this diagram shows only a single quadrupole mass spectrometer. This contains the ionization source where our analyte or the outlet of the HPLC is connected with the ionization source, and here the liquid analyze or the gaseous phase analyte got ionized using in the ion source. Then they reach up to the quadrupole or different type of mass analyzer, and they are further detected by using the photomultiplier tube or particle multiplier tubes. So this is all about the HPLC. And talking about the mass spectrometry, so mass spectrometry are the analytical techniques which employ the analysis of any chemical or elements present based on the mass to charge ratio, and these chemicals are basically analyzed in the form of ions. So in mass spectrometry, the principle is based on the ionization as well as the uh, mass by charge ratio, as well as the detection and the abundance or the kinetic energy present inside the ions. So based on these different type of principles, mass spectrometer there are different type of mass spectrometer available now. Talking about the components of the mass spectrometer present, so in any mass spectrometer, the major components are the ion source, which ionize the sample, or where the ionization of our analytes happen, and mass analyzer. So these mass analyzer basically separate as well as analyze our analyte based upon mass to charge ratio, and detector is also the quadrupole or maybe triple quad or TOF. So they are the same. Sometimes it acts as a separator, sometimes it act as a filter, or sometimes it act as a detector. The same instrument assembly uh, can be employed in a different form, and also it contains the data system, that is a basic computer system. Talking about the ion source, so there are different ion source present to ionize different type of molecules or sample. So this ion source basically ionize the sample, which then further go inside the mass spectrometer and then got identified and quantified. So in the ion source, the liquid or gaseous phase analytes got ionized based on the different type of ionization technique. These techniques can be like electron ionization, ESI or MALDI, etc. So uh, uh, how would you determine like which type of ionization source you have to use? It is based on your requirement, that what type of analytes you are going to analyze. If you are going to analyze like a protein, so protein has a higher molecular weight, so you can use MALDI or like ESI, or sometimes desorption ESI. And uh, and if you want to analyze like some compounds such as like pesticides or the organochlorines, then you can go for electron ionization. So and the quantity of ionizations is also depend how much voltage you are applying in the ion source, as well as the temperature you are applying for any specific analytes. Some analytes, like talking about the smaller molecules or the analytes such as pesticides or pharmaceuticals, they are not much higher in the molecular weight. They are less than maybe 100 daltons or 1000 dalton or 2000 dalton. So you can use any soft ionization technique such as ESI. But when you are talking at ESI at like 200 or 300 degrees Celsius, but when you are going to analyze higher molecules such as peptide, which are having molecular weight greater than 2000 kDa, then you need higher voltage as well as high temperature, like 600 degrees Celsius. So based on the analyte you want to analyze, you can uh, play with the parameters of ion source for the analysis. So there are a different type of ion source. Talking about the ionization, so there are two type of ionization: hard ionization and soft ionization. ionization. So in hard ionization, high energy is imparted on the analytes, and these analytes got extensively fragmented. Sometimes they destroyed the original compound present in the analyte, and their daughters or fragments can be detected using mass spectrometer. So EI, electron ionization, or high energy photo bombardment ionization are the hard ionization technique. These ionization technique, hard ionization technique, provide complex spectra and multiple fragments of a ion, and this sometimes make analysis or the mass uh, spectra analysis difficult. And they are employed, this type of ionization or hard ionizations is employed for the stable compounds or highly stable compounds. When you are talking about the soft ionization, so here the energy imparted on the analytes or molecule is low. So this soft or the low energy preserve the parent molecule as well as the daughter molecule, and the fragment generated here are limited, and so you can analyze multiple compounds in a single run. These techniques are generally used with the liquid chromatography. Soft ionization is basically used for the thermolabile compound, or like you can say fragile compounds or biomolecules. Soft ionization technique can be used. So nowadays, like highly used techniques are the soft ionization, because hard ionization destroy the molecules entirely. Talking about the electron ionization, so this ionization is present in the gas chromatography. With the gas chromatography, what happens in this ionization here, an electron beam is like flow through the different in between different electrode, and when the analyte come in between in interaction with the electron beam, these electron got interact with the analyte, and they will uh, emit out one electron from the analyte. So in this way, this like neutral analyte got charged by ions, and these ionized analyte further go for the mass analysis. uh, so here fragmentation is like at once, and it is extensively or highly fragmented. So in GC you can see like multiple ions generated within a one analyte. Talking about the electrospray ionization, this is the mostly used soft ionization technique. This is basically used for sometimes TOF, sometimes with the triple quad or single quadrupole mass spectrometer, ion trap mass spectrometer. So I have also used like this at like very much times. Talking about the electrospray ionization, so what happened here, analyte come with the nitrogen gas inside the capillary, and this small capillary, when it come outside the capillary, this nitrogen will nebulize the analyte and the atoms present inside the analyte, and these atoms and then sprayed by the electron from electrodes. So these electron spray from the electrodes ionize the analytes, and these ionized analyte goes inside the mass spectrometer, and the analytes which are neutral or non-ionized, they go inside the waste. So this is basically used for analysis of pharmaceuticals, pesticides, pesticides, as well as the biomolecules such as nucleic acid, proteins, peptides, etc. So this is highly utilized ionization technique. Talking about the MALDI, that is a matrix assisted laser desorption ionization. So MALDI is generally used for the protein profiling or in the proteomics analysis. So here what happened, proteins are the large molecular weight molecules. So they are generally um, like uh, fitted inside a matrix, and or embedded inside the matrix. So when laser beam is fall over the matrix, so these protein molecules got dissolved. So that is the desorption, and then these dissolved molecules got ionized, and these ionized molecule go inside the mass spectrometer for further analysis. So MALDI is generally used for the proteins or polymer or the highly molecular weight analytes analysis. Talking about the atmospheric pressure chemical ionization, so this is older version of, you can say, ESI ionization. So here what happened, uh, in the ESI, the ionization happens inside the vacuum or the high flow of nitrogen. But here, it is ionization happens in the atmospheric pressure. So this is the similar to the ASI. Here is the corona discharge, which provide a electron beam to the analytes, and these analytes got ionized and further detected with mass spectrometer. Talking about the desorption electrospray ionization. So in desorption electrospray ionization, what happen, you sometimes you do not require any HPLC or GC. You can directly analyze any compound or any sample by using this technique. You just put the sample inside the uh, desorption electrospray ionization chamber, and these samples, there is a gas jet or the nitrogen gas, which is uh, flowed with a high pressure and in a potentially uh, controlled chamber. So this high pressure of the gas and the potential generated inside the chamber dissolve the samples from the analytes from the sample, and these samples got ionized and further analyzed by the mass spectrometer. So this technique can be used for analysis of tissue sample as well as any biological sample, or in the forensic science you can say any viscera. You do not have to extract, you just put the some drops of viscera or pieces of viscera over the DESI, and it got further ionized without any processing. Talking about the chemical ionization, so there are some species which require to which require ionization by using some uh, chemicals, or the so in the chemical ionization, methane is used for as a reactant gas. So methane is react with electronegative compounds, and these here is the reaction for the methane reaction with any analyte containing electronegative compound, and these electronegative compound then uh, form a adduct with the methane and got ionized in the chemical ionization chamber. Then these ions go to the mass detector for the further analysis. Talking about the mass analyzer, so we have finished ion source, different type of ion source. Then after the ion source comes the mass analysis. Like our analyte got ionized but not quantify or identify. So for quantification or identification, we require mass analyzer. So in the mass analyzer, what the triple quadrupole or TOF, they separate as well as analyze any ions present in the sample based on the mass to charge ratio. Sometimes mass analyzer act as a collision cell. Sometimes it act as a filter to elute out a non-targeted mass, and sometimes this filter work based on the DC and RF combination. So if you change the DC and RF combination, then they will filter like high molecular weight, and if you like change it to another way, then they will filter the lower molecular weight ions. So the mass analyzer can also be act as a filter to separate multiple or major ions from the minor ions. And sometimes these mass analyzer also act as a trap to uh, to trap any molecule or ions inside the system based on their potential energy. Sometimes they also trace any molecule based on the kinetic energy present inside the molecule. So they based on the different type of analytes you want to analyze, you can utilize mass analyzer differently. Talking about the renowned mass analyzer, that is a quadrupole mass analyzer, which you already if maybe heard about the quadrupole. So here there are four rods. Here you see four rods arranged parallelly to each other. So these like two opposite rods, this rod and this rod are attached like having DC. Then this rod and this rod like parallel, not perpendicular rod may have the RF. So based on the DC and RF combination, you can filter or analyze any mass by charge ratio. Uh, and based on the filter or the DC and RF potential, you can analyze smaller as well as the higher molecular weight ions. Talking about the time of flight, so time of flight is basically a mass analyzer in which the ions got separated based on their molecular weight. So if any ion is having the less molecular weight, so it is lighter in weight. So this molecules take less time to travel a certain distance. So this is the path length, and a difference in the path length between the ions can is helpful to analyze what type of ion is present. So top is basically used for untargeted, sometimes a trace analysis, and sometimes in the proteomics or metabolomics kind of analysis. This is a high resolution mass spectrometer, and the quadrupole is the high sensitivity mass spectrometer. Talking about the ion trap analyzer, so in the ion trap analyzer, uh, there are the ring electrodes, so which trap the ions based on their specific uh, potential in between the magnetic field, and based on the change in the magnetic field, these trap ion then further go to the mass spectra or photomultiplier tube for the detection. So in this, what happen if there is a less quantity of analyte or ions present in the molecule, then you have the you can say ease or accessibility to concentrate these small ions into a multiple or number cluster of ions, then you can send it to the detector. So this is the ion trap analysis. So here you in this mass spectrometer, you trap the ions and then analyze them. So this is a highly sensitive mass spectrometer. Talking about the magnetic sector analyzer, so in this in quadrupole we use the DC and RF potential, but here we use the magnetic or electrostatic charge to separate the ion. If hello, am I audible? Okay, am I audible? Okay, so talking about the magnetic selector, so based on the magnetic potential and electrostatic potential, these analysis the our analyze can be analyzed using the mass spectrometer. Talking about the wait, orbit trap analyzer, so in this there is a orbit or the trap. It is kind of similar, kind of like ion trap analyzer, but in place of potential, here we use the kinetic energy to trap any ion, and based on the oscillation frequency, you can trap any specific ion based upon the mass to charge ratio as well as the kinetic energy. So you can like filter the ions which you do not want, and you can concentrate the ion which you want to analyze. This is also a highly sensitive technique for the spectrometry analysis. Talking about the FTICR, so that is Fourier transform ion cyclotron resonance mass analyzer. So this is basically a improvised version of ion trap mass analyzer. So in this, the ions got accumulated, and then they are like, and their kinetic energy is used to rotate in the cyclic motion inside a magnetic field, or these magnets are the superconductive magnets, and based on their frequency, there is a like data capture based on the intensity as well as the time frame, and this intensity and time frame data is then transformed using the Fourier transform uh, you can say formula, and this time and intensity frame is then converted into the frequency and intensity frame, which is further converted into intensity and mass to charge ratio. So based on the electrostatic field and their oscillation frequency, you can analyze or any compound or any ion present inside the molecule. So this is also a high resolution and high mass accuracy up to the 4 digits of the Dalton. So this is a highly specialized techniques. You have sometimes listened about the mass spectrometer or tandem mass spectrometer. So what is the difference in between two? In talking about the mass spectrometer, so there the mass spectrometer is only containing the single quad, or that is like Q1. So here you see the quadrupole. There are four ports arranged parallelly to each other with the ion source and the detector. So this is a simple mass spectrometer. But when we are talking about the tandem mass spectrometry, so what happened? In place of single quadrupole, we have the triple quadrupole, and these quadrupole can be first quadrupole can be like in maximum number of system. This first quadrupole is a first mass analyzer is a quadrupole, and second and third quadrupole is acting as a collision cell in tandem mass spectrometer. So what happened here? It detect the parent ion, and these parent ion then further go to the uh, collision cell. So this collision cell, it got fragmented by the bombardment of gases, that is a nitrogen inside a vacuum, and this parent ion got fragmented into daughter ion, or the fragmented ion. So these fragmented ion then comes to the second or the third quadrupole, where these parent as well as daughter ions are detected. So this is like a parent ion, collision energy, and daughter ion. So this is three terms are combined together, is termed as the mass multiple reaction monitoring, or MRM, in the mass analysis or tandem mass analysis. So if you are having a triple quadrupole instrument in your lab, then this is the assembly. Sometimes you heard that you have triple TOF in your lab. So then in place of quadrupole, there is a TOF mass analyzer in place of these three quadrupoles. So that is a triple TOF. Sometimes QTOF. So first is the quadrupole, second is the quadrupole, third is the TOF analysis. So based on the type of the mass analyzer you are using, you can analyze different type of samples. So if you are analyzes only mass, parent ion, daughter ion, then it is termed as MSMS. Sometimes you see in the literature or paper that it is MS to the power n. So you can fragment the daughter ion multiple times. So like if you fragment the parent ion first time, it converted into daughter. Here you can again fragment the daughter ion into further daughter ion, and again further again fragment the daughter ion to further daughter ion. So that is MS to the power n. So this is a tandem mass spectrometry. Talking, we have already discussed the HPLC as well as mass spectrometry. So here is the instrumentation. So this is water's equity UPLC system combined with the AB6 API 4000 triple quadrupole mass spectrometer. So this is used for generally used for the separation, and this is used for the detection. This machine is having high sensitivity, and here you see the ion source, and here inside this tube is the quadrupole arrange, and in the lower portion it is an electronic system, like the controller and other things. And if you do not want to use the HPLC, then you directly inject the system in this mass spectrometer. So here you see a box, this blue box. So this is a direct injection system. So you can directly inject your analyte into the mass system and get them analyzed. Talking about the results, so when you are using instrument for the targeted analysis, so you have to develop the multiple reaction monitoring reactions or the mass reactions for each and every analytes you want to target. So these targeted analysis are highly sensitive. You can detect your analyte up to the PPT level, that is parts per trillion level, that is very much less. When we are talking about the any forensic sample, then the poison or the metal or any other tentative analyte is present in like much higher concentration. But when sometimes happen the because you got visra after like maybe 1 year after or 2 year after, so then there is a chance of degradation, so you are not able to find that much quantity of the analytes. So for that you require a targeted analysis containing the high sensitivity instrument, or HPLC attached with the mass spectrometer, or triple quadruple mass spectrometer, you can specifically say. So based on the targets, you can analyze up to the trace level or the parts per trillion level. Coming about the untargeted analysis, so this is the area which is, you can say, is known to everybody, but not much work is done in this field, because untargeted analysis is basically employing the characteristics of the mass spectrometer with the HPLC. So here you not only separate the different analytes based on the retention time, you are also separating the analytes based on their mass fragmentation, based on the collision energy, based on their parent and daughter ion combination. So this is untargeted analysis. And in the targeted analysis, like if there is a case of organophosphate poisoning, you know that particular person is died, or there is a smell of organophosphate or phosphine gas in the sample, then you can go for organophosphate targeted analysis. But what happen if the viscera is questioned, like they don't know what is the poisoning, what is the reason of the death, then what you do? So for that, you can go for the untargeted analysis, and you just run the extract the analyte and run the full scan, and then you go for the mass fragmentation pattern and analyze the compound. So in this is the way to analyze any unknown compound. And it is like, you cannot quantify, but you can say this compound is present inside the sample. If you want to quantify in untargeted analysis, then after the untargeted analysis, you have to go for the targeted analysis for the quantification. So untargeted analysis is only the quality check, or you can say this much times a particular sample is present. Like if you are comparing two samples, like a blood sample of a deceased and blood sample of a normal human, then you can say that, okay, this normal human contains maybe 5 ppb of the not 5 ppb, like 1x ppb of chromium 6, and the disease contain 10x uh, of the chromium 6. So you can say that, like in the untargeted analysis, but you cannot quantify like how much microgram per ml is present in the untargeted analysis. You have to go for targeted analysis in that. Talking about the liquid chromatography with inductively coupled plasma and tandem mass spectrometry. So this is the instrument for liquid chromatography system. It is basically a HPLC system employing the ionic column. And here is the samples for direct injection of liquid chromatography. If you want to specialize CSN of any chromium or any other ions, then you can use the auto sampler from here and got it separated from the ionic column and then detected by the plasma. So this is the plasma chamber. So when any analyte got separated from the uh, liquid chromatography, they then go to the plasma chamber where they got ionized, and this chambers contains the mass spectrometer. So they are here the detection is happening based on the similar principle of mass to charge ratio. So this is the result for chromium 3 and chromium 6. So why the chromium 3 and chromium 6 is important, I already told, because chromium 3 is less toxic as compared to chromium 6. Chromium 6 is like 100 times potent than chromium 3 ions. So sometimes you require chromium 3 and chromium 6 speciation, CSN. Sometimes when you are talking about the drug trafficking thing, you want to analyze the origin or the source of the drug, like from where it is originated, or from which region of the world a particular opium or the byproduct of opium comes from. So there you can analyze, utilize LC-ICP-MS for analyzing the isotopes or the different ratio of the isotope present in any sample. Like you can analyze the nitrogen as well as the oxygen isotope present inside the sample, and then you can say, okay, this opium is generated from Afghanistan, this opium is generated from the Laos, based on the isotopic ratio. So this is also helpful in the drug trafficking control. Talking about the forensic application of liquid chromatography as well as mass spectrometry, so it can be utilized for the detection of the any uh, explosives or the any compounds or the polymers. It can use for the detection of the dyes as well as ink, It can be used for detection of any type of toxicant present in the blood sample. Usually, you already know that GC and as well as HPLC is used for like alcohol detection, but generally people prefer GC for the alcohol detection. But you can also analyze alcohols and their contaminants. Sometimes the metal contaminants, other thing are present with the alcohol, so you can use like liquid chromatography with mass spectrometry to analyze them. You can analyze any poison based on the mass to charge ratio by using LCMS. You can analyze arson as well as the traces of arson or burnt pieces. You can uh, analyze by using HPLC as well as GCMS. You can analyze drugs and pharmaceuticals and yeah, definitely pesticides. So talking about the scope of forensic toxicology, or you can say forensic chemistry. So these are like some scope of like forensic, apart from like forensic science lab or any detective agencies or any university. You can go for the like defense organizations such as DRDO in India, and here in US you can go for National Defense Laboratory, and you can go in the industries for the quality control and quality assurance thing. You can also go for the product testing and product management, you can say uh, product management or quality control thing in the industry. You can go for NIDA. NIDA is a drug regulatory agency for United States. You can apply for there too. And of course, CBI, you can go in the CBI as well as the Space Research Organization. Somebody thought like, oh, how the forensic scientist or any like analyst who are expertise in the HPLC and GC go for the space research. You can go because we are as a human, we are much concerned to not send anything unwanted in the space, so they require the analyst like us. And you can go for regulatory agencies such as I'm working here for NIH, FDA, CDC. So you can go for them in the job. And you can also go for UNODC, that is United Nations Office of Drug and Crime. So they also have the specific forensic vacancy, and you can go to any R&D services wherever you want if you have a specialization in these type of techniques. So this is the end of slides from my side. So any questions you have, doubts, you can ask.
Thank you, sir, for the engaging and profound session. So we have two questions from the participants.
Okay.
The first question is, in toxicological samples, what is the
Mhm.
usual window period for the analysis of drugs of abuse from blood, hair, and nail, and which matrix is most effective?
Okay, so based on that time period, it is based on the storage condition as well as and the life of the drug. So talking about like mm benzodiazepines, if they are kept inside the minus 80, you can analyze them up to like maybe 10 years or 20 years. But if they are stored inside like minus 20, they can be analyzed up to 5 years. If they are stored at 4 degrees Celsius, they can be analyzed up to 1 year maximum. But if they are kept in a room that is general condition in India, so they cannot be analyzed like much further because they are inside the biological system. So benzodiazepine then further got metabolized into their metabolites. So in place of going to the analysis of parent ion, you can go for the metabolite ion detection in these type of biological samples. So the lifespan of any analytes present in the biological samples depend on the matrix in which they are present as well as the storage condition. Talking about the here is like a highly preserved sample. So you can analyze drug of abuse up to a much higher duration in the hair and nails as compared to the blood or serum.
Thank you, sir. The second
Yeah.
question is, which analyzer is mostly used in the analysis of opioids?
In the analysis of what?
opioids?
Opioids. So analyzer of you can go for both, like mass analyzer is basically utilized in the industry as well as in the regulatory agencies. So I have one case of the opioid. So there is a person giving some, not person, there is a, you can say in India there are like jhulat chap doctor. So they gave some drug to an old scientist, that is a renowned scientist. He is not, he's like body aching in pain and much, and the jhula chop doctor gave some jadi booty to that thing, that doctor, that scientist, and he is eating it continuously. But when he discussed it with our director, so he just told like, you can go and analyze this, and there comes a trick. So director told us like, you can go and analyze for cannabis, that can be good. So I do the target analysis because director already told that it contains, it may contains cannabis, and we analyzed cannabis, we didn't found it. So there is a targeted analysis, but based on the story or the description given by the director, I just told my boss like, we can go for the non-targeted analysis and find what is really present inside that medicine. If the medicine given by Julat Saab doctor, maybe it is beneficial, something we can found. So this is kind of R&D. So I just go for untargeted analysis by using gas chromatography and mass spectrometry, that is triple quadrupole mass spectrometer, and we inject the extract the sample by using different type of solvent, like uh, methanol as well as the hexane, and combine them both, and evaporate them using liquid nitrogen, and further we can we reconstitute them using acetone, then we inject it. So we find like yeah, opioids in that, as well as it contains some of the benzodiazepines in that. So these two combination is given to the scientist, and he is like, oh, much calm by having the medicine. But the thing is that sometimes it is based on the like like somebody is asking something, like my director is asking to analyze cannabis or cannabinoids. But when you are in a question, or you are in a confusion, then you can go for the untargeted analysis. It happens that cannabis may be present sometimes in less quantity, but higher quantity of some other drug can be possible. So the mass detector is like very much suitable, and because it is not the like too closely relying molecular ion, so you can go for triple quadrupole. If you are talking about like too closely allying molecular ions, such as the isomers of cypermethrin, so then you can use TOF for high resolution in between peaks. So based on the sensitivity, you can go for triple quadrupole. If you want to go for high resolution, you can go for triple top or iron trap.
Thank you, sir, for patiently answering our questions. As we express our gratitude, we must never forget that the highest appreciation is not to utter words, but to live by them. With these thoughts in mind, I invite Ms. Yadupriya P., second semester MSc student, Department of Forensic Science, to deliver the vote of thanks.
Okay. First, I will thank you, all of you.
Thank you, Neha. Good morning, everyone. On behalf of Jayanti College, I extend our heartfelt gratitude to Dr. Ravindra Singh Thakur for taking the time to share his expertise and insights with us today. Dr. Thakur's valuable contribution has enriched our understanding and inspired us to delve deeper into the realm of application of LCMS. This session would not be possible without the support and guidance of the members of management led by the Principal Reverend Father Dr. Addison George and Vice Principal Reverend Father Lijah P. Thomas. Thank you, Fathers. I would also like to thank Mr. Don Carroll, Coordinator of Department of Forensic Science, and the faculty of department for their support in making this event possible. To our audience, thank you for your active participation and thoughtful questions. Your engagement has truly made the session insightful and meaningful. Let us carry forward the knowledge and inspiration gained today into our work and studies. Thank you once again, Dr. Thakur, and to everyone involved.
Thank you all and have a nice day. If you have any further like doubts or clarification or uh, any guidance you want, you can just contact your like uh, teacher Nandini Katari, and he just like message me, or you can directly get my mail ID from her and contact me directly. No problem. Thank you very much. Okay, Nandini, you are muted or you are not audible. Okay, thank you. Okay, bye. Have a nice day ahead.